Welcome to SpaceTime with Stuart Gary.
Mission managers at the European Space Agency are still struggling to re-establish contact with the Schiaparelli Mars lander. The 577-kilogram spacecraft lost contact with ESA Mission Control in Darmstadt, Germany, during its 6-minute journey to the surface of the red planet. ESA's Director General Jan Warner says the agency doesn't know yet if the lander reached the Martian surface in one piece, a viewpoint backed up by ESA's Spacecraft Operations Manager, Andrea Camazzo.
I think it's very difficult to say a likelihood now. The problem is that there were some conditions under which the lander should have landed, and this we judge it as soft. Unfortunately, we are not in a position yet, but we will be, to determine the dynamic condition at which the lander has touched the ground, and then we know whether it could have survived structurally or not. We are not in a position to say this now because we don't have any data. So we are still processing the data of the descent. From the surface, we have no data at all. The TGO is not planned at all to listen to DDM. It's an on-orbit where it cannot perform this action anymore. Could perform it during the descent, but that was it. This is absolutely nominal. So the TGO cannot hear anything from the EDM. We had 2 additional overflights of MRO, during which no RF signal has been recorded at all. So it's not that the data are confused, there's no RF signal. So definitely we have no evidence. We will keep monitoring. The EDM is meant to do a session in so-called open loop. So transmits again a radio signal, which Mars Express and the Pune radio telescope might pick up. So this we are listening in. MRO later performs another overflight, we'll listen in. So we keep monitoring from the EDM. If there is a signal coming, we would pick it up for sure.
Orbital images of the landing zone show what appears to be a crash site and evidence of an explosion. Analysts say the Schiaparelli probe appears to have fallen up to 4 kilometres before slamming hard onto the Martian ground. Earlier, Schiaparelli had successfully separated from the ExoMars Trace Gas Orbiter mothership as programmed on the 17th. While the ExoMars Trace Gas Orbiter successfully conducted an engine burn to achieve Mars orbit insertion, the Schiaparelli lander cruised to an altitude of 120 kilometres above the red planet's surface and then began its EDL, or atmospheric entry, descent and landing phase. The cone-shaped probe entered the Martian atmosphere as planned on the 19th, using a combination of heat shields, supersonic parachutes and rocket thrusters to slow down from 21,000 kilometres per hour to just 4 kilometres per hour for what should have been a soft landing, in the process testing new technologies to be used on a future European Mars rover mission slated for 2020. ExoMars was launched in March as a joint European Space Agency and Russian Federal Space Agency mission with the primary goal of studying the Martian atmosphere. Mission managers lost contact with Schiaparelli just moments before it was due to touch down on the Meridiani Planum. NASA's Deep Space Communications Network's Madrid tracking station had just taken over from the Canberra tracking station about 50 minutes before the expected touchdown. Everything was going as planned when, just a minute before the anticipated touchdown at an altitude of less than a kilometre, all contact was suddenly lost. The timing matches to a point in the descent phase when Schiaparelli's parachutes were to be jettisoned and its 9 CHT-400 hydrazine thrusters were to be ignited to further slow down and stabilise the lander. At this stage, it's not known if the parachutes or the thrusters malfunctioned. Mission managers have confirmed that the entry and descent stages of the flight were occurring as expected. However, it seems events began to fall apart following the ejection of the heat shield and the parachute. The ejection itself appears to have occurred earlier than expected, and although ESA were able to confirm that the thrusters were briefly activated, it seems they may well have switched off earlier than expected, forcing the lander to fall to the ground. NASA's Mars Opportunity rover, which is also exploring the Meridiani Planum region, had its cameras pointed towards Schiaparelli's flight path for the lander's descent. Its observations, together with all the available telemetry from Schiaparelli and data from other NASA and ESA orbiting spacecraft, are now being carefully sifted through to try and determine exactly what happened. For ESA, this is the latest in a string of lander failures. In November 2014, the comet-chasing Rosetta spacecraft's Philae lander failed to touch down as planned on the surface of the comet 67P Churyumov-Gerasimenko, instead bouncing across the surface and ending up on its side in a dark ditch. And ESA's first attempt to land on Mars, way back in December 2003, also ended in failure. The Beagle 2 spacecraft, which had flown to Mars aboard the Mars Express orbiter, suddenly lost contact during its descent to the red planet's surface. In January 2015, NASA's Mars Reconnaissance Orbiter spacecraft finally spotted the Beagle 2 intact and safely on the surface at its Ascidius Planeta landing site. However, it also found that 2 of the lander's 4 solar panels had failed to deploy and were blocking the spacecraft's communications antenna. Meanwhile, the primary mission being undertaken by the ExoMars Trace Gas Orbiter is continuing smoothly. The probe is studying the Martian atmosphere, looking for, among other things, traces of methane. Methane's been detected by both spacecraft at Mars and also Earth-based observatories, raising considerable speculation and excitement among astrobiologists. You see, although methane can be produced through geological activity, its most common source here on Earth involves biological processes. Now, while scientists aren't expecting to find Martian cows, the methane they're seeing could be a byproduct of subsurface bacteria, archaea, or other extremophile microbes, and therefore could herald the historic first ever evidence of life beyond Earth.